Ladies and gentlemen, please welcome to the stage Mr. Scott Drennan, VP of Innovation at Bell. Mr. Jean-Baptiste Jarin, VP Program, Hybrid Propulsion Systems. Mr. Didier Papadopoulos, VP Aviation, Program Systems and Business Development. Mylène Tassy, Director, Sales and Marketing. Mr. Nathan Millecam, CEO, EP Systems.
Well, panelists, welcome, and thank you all for being here today. And Bell, thank you for having me. Scott, I'd like to start out just looking at the Nexus. I mean, this is something that's different from anything that Bell has displayed at Heli-Expo before. Could you maybe talk a bit about when you came up with the concept for this aircraft? How did you go about, selecting the partners who would be involved in this? What were you looking for? And then maybe we can hear from each of the partners why they felt they would be good to contribute to a new project like this.
Well, I'm going to use an old favorite phrase of mine that all of our Nexus team partners are familiar with, and that is, I was looking for capable believers. Those were the two criteria. If you aren't capable of generating an aviation-grade, safe, high-quality, productionized vehicle, then you weren't going to have the conversation with us. If you were, but you didn't believe, you weren't going to have the conversation either, because this is a new market space that we're all going into together. So you had to be fearless with us, believe in the future of vertical lift. And so the team that's up here today is a group of capable believers, and that's the best way I can describe them.
Great. Well, maybe we can just go down the line, and lucky you. And just tell us about how your company sees your contributions to this project and the future of eVTOL urban air mobility.
Well, that goes to innovation basically, and what we can propose, and for that we've been sharing the innovation motto with Bell for almost as long as them. We are very old companies for that, and we thanks Bell for bringing the creativity that we're there to meet a market demand, and basically we are, as Scott said, we are believers for that market demand. And so what Safran will bring to that is basically merging the safety and the quality requirements that drive Safran for decades to that entrepreneurship that we are having with the Nexus team and Bell and all the colleagues here today.
Okay, jump in here. So maybe for some background, Garmin's contribution to the system is really around navigation, communication, and aircraft systems management. So that's the component we contribute in. Why we're here, first and foremost, because we do believe that there is a real opportunity for platforms like this to serve the aviation market and the broader community, whether it be urban community and so on. And then the team here I'm sitting with is really the team that stands for innovation. To kind of copycat your word here, we think that this is an opportunity for us to take the technology that we have at hand and apply it in a different way to serve the markets we're looking at here.
For Thales, we're going to supply the flight control computer and be responsible for the flight control system architecture, interfacing with the propulsion system, the avionics system, and also the actuation system from Moog. And really for Thales, innovation is at the core of our DNA. There's a 30 or 40% of our engineers are lent or full-time into innovative project from the beginning. So it's important for us to be here with Bell in something we feel will revolutionize transportation and be at the forefront of change.
So I'm Nathan Millecam, Electric Power Systems. So we supply the energy storage system for the Bell Nexus. So quick terminology, why do I call it an energy storage system and not a battery system? Well, a battery is a device that stores electrons, and we have thousands of those devices that we are deploying on this aircraft. And when you configure those devices at high voltage and high capacity, suddenly a whole host of other technologies become really important for that system just to operate. So those technologies include thermal management systems, power management systems, software and control layers. I think what we contribute to this project is we're probably the only one here that's not a 100-year-old aerospace company. We represent a spirit of entrepreneurship that is happening in our industry that likely hasn't happened since the dawn of the space age. So I think we bring some of that innovation, some of that lean methodology to work well with established players who have been doing great things.
Excellent. So Scott, let's talk about the hybrid propulsion system. So first of all, I'm interested, why did Bell decide to go with a hybrid system rather than a full electric aircraft?
So when we first started looking at the market opportunities, we saw a couple things that were out there, including civilian logistics markets and military markets that told us there's a range ring out there around 150 miles that we needed to try to hit in order to serve some of those longer missions that weren't necessarily being talked about in the urban air taxi sector of the opportunity. And Bell's history is been about providing broader mission capability sets for our customers, and therefore we thought, well, let's stretch out to that range first and foremost. Second, we asked ourselves where the technology was with batteries, and Nate has taken us on a great journey since that time and has opened up future possibilities of all electric aircraft as well for us. But we looked at it then and thought hybrid is a better route to get to certification, to wait on the electric, fully electric vehicles to do a mission like this. And so the combination of that broader mission capability set and our ability to certify and wait on the capability of the batteries to get to a level at which we expected Nexus to perform was the perfect kind of storm towards picking hybrid electric to start off with.
So let's talk about some of the details of the propulsion system. Maybe Jean-Baptiste, you can talk about your company's contribution, and then Nathan, we can go into a bit more detail about your contribution. And then I'm really interested in how those two systems interface.
Well, we are the key, in fact, of the Nexus with the propulsion system, and you're correct. Our two systems interact, I would say, on the daily routine. I would say. So what we are having is what we call the hybrid electric propulsion system. So in terms of equipment, that goes from a turbo generator, which will generate the amount of electrons that are required to generate the power to the motor that will propel the aircraft on board, and we have all the distribution associated to it that comes from two major companies of Safran Electric and Power and Safran Helicopter Engines. And as an integrator, that's where we're going to work closely with EPS and of course Bell, is that we have all the management of that energy and making sure that we use wisely either the turbo generators, either the batteries, or a combination of both during the different phases of the flight.
So as I mentioned, energy storage system, maybe in a little more depth of something that's unique about our energy storage system and how it enables the hybrid architecture is we're deploying what we call an active battery management system. And so one of the unique things about cells is as you start to charge them and discharge them multiple times is they get out of sync with one another. And that becomes a problem on the bottom of the charge cycle because you're always limited by that weakest cell. So there's a lot of strategies to try and keep them in synchronicity, but what we do is real-time power management where we can transfer current from one stack to another stack to make sure that they always stay equal. Well, once you deploy that type of topology and you can actually certify that topology, suddenly you can start to do interesting things where you're integrating some of the power buses at lower voltage or looking at things of how do we do filtering on the power bus that really makes us very closely tied to the overall system that Safran supplies.
I'd like to say one other thing that the two of our teammates do from Safran and EPS. We really have, sometimes I think about it as three propulsion systems on board. One that's operating integrated throughout the entire mission. One that is a hybrid electric system that can do parts of the mission that a battery system alone couldn't do, and then the electric portion that, because we've chosen a single engine, the hybrid electric couldn't do. So it's really the core, their integration is the core to our safety approach. We have two systems on board, one that can fly us through our entire mission in the form of the hybrid electric, but then Nate's system on board that can get us to ground under full power, full control, should there be a contingency event. And I think that can't be underestimated in terms of this team's philosophy towards safety, because that choice doesn't come for free. It comes from a place of value and safety for our customers, but it costs some extra weight, some extra work together, and it's a testament to both Safran and EPS that we're able to even have a viable system that can do both of those things and still perform the mission. That's what's incredible about it.
Cool. So obviously, you guys are all working much more closely together than many companies and suppliers work on traditional aircraft projects. So maybe you can all talk about the process of how you do interface and collaborate to meet some of these challenges.
Maybe I can jump in and talk about a few examples. One of the things that we do, for example, with the mission computation, which is determining where we're going, how we want to get there, and so on, those decisions often, or for the most part, translate into distributed decisions across all the systems, one of them being flight control as an example. And so we may decide that we want to go from point A to point B. In a conventional system, our responsibility, that of the flight control and so on, is very rigid to some extent, driven by older technologies, development processes, and so on. In this case, we're all sitting together and talking about, okay, what is the intended function? Where do we want to get? And then collaboratively deciding, okay, where is that function needing to reside? What is the most effective architecture for that to reside, so that we don't have 3, 4, or 5 boxes. Instead, we can maybe have 2 boxes, so save on weight, power costs, and all those things. So that's the type of discussion that we have regularly amongst each other.
I think maybe just to build on that, one thing that's unique about this development that you typically don't see in other aircraft developments is transparency, and really credit Bell to doing that. If there's a challenge, we know about it, and we all work on it, and we solve it together, rather than traditional aircraft development, whatever system might be challenged, or the airframe, or whoever has that responsibility, you may never even know about that. Sure.
Great. So Scott, you mentioned Bell's approach to safety earlier. So with a brand new aircraft like this, there are a lot of safety concerns and a lot of unknowns. So maybe we can talk about what are some of the big safety issues you see in deploying a brand new aircraft type like this, and then maybe all of you can talk about how your companies are addressing those aspects.
Yeah, thank you. So inside that capable believers, by default, capable means you value safety and you're able to engineer it into your vehicles. But just if you take a look at Nexus, you would say, well, let's look at the lowest TRL type opportunities, and those are usually where your safety challenges come from. So we have a new hybrid electric system that integrates Safran's equipment with EPS. We have a distributed system that's a big challenge to us. It's smaller rotors that we have to control in a different way, and then ask Thales and Moog and our partners to control in a different way with new control laws that may seem similar to, oh, hey, it's Bell, they do tilt rotors, they know how to do powered lift, but this has a lot of differences between the two. There's some foundational aspects that can help us there, but we have to be safe in that way. We're going to eventually ask the combination of Garmin and Thales and maybe some other partners out there to do this autonomously. There's big safety concerns there. Can we do all the things that a normal pilot can do, even better when we change to an all-autonomous vehicle? And the great part about it, and I think you hear it in our teaming talks like this, is none of those are so daunting that we don't just face them head on and take care of it. And that comes from all of our shared value system about safety. You saw the image that Nate showed on his video of the kids in the car. That's why I can sleep at night, because I know I'm not going to let anything get past my team as best I can for my family and my friends and the public. And I feel confident, and I know that this team does the same thing all the way down through their whole organization. So there are challenges because the technology's new, but we've created a team that can handle all of them and make a safe product.
I can just add something. So in terms of what we're bringing to the Bell Nexus, we bring a very mature flight control computer technology, strong with over 30 years certified. So, but we're looking at the next step. So we have already a high availability, high integrity with redundancy system integrated into this demo, interfacing with our partner here and being the system integrator of the different system. But we're also looking at the next step, as Scott mentioned, autonomy, of designing our next generation flight control computer with a smaller footprint, which will be able to have incremental certifiable step change, which could support autonomy, bringing also together AI, cybersecurity, connectivity, etc.
And maybe to go on, I think when you see the aircraft, the safety is there by design. I mean, you have 6 rotors. We have 2 engines per rotors. We have multiple segregation. Bell relies on its experience and on the experience of all the companies here, Thales, Garmin, EPS, and us. Safety is at the DNAs of Safran today. And the challenge for us is not basically the level of TRL of each technology, because all the technologies we apply to the Nexus, they exist today. What's new for us is the merging of those technologies. And that goes for Safran. We have to merge the technologies of basically almost all of the group companies within Safran, and we have to make sure, and Bell is very good at that we are merging the technologies of all those companies and that they match well together. But this is where our challenge is today, but where we are very confident regarding the safety is that by design, this type of multi-rotor, electrically distributed propulsion is inherently safe by design.
So. And Nathan, I know that there's always, concerns around batteries. So how are you addressing some of those safety concerns with your company's contribution?
So that's a really good question. Our approach is actually to first start where regulations are. We've come a long way with aircraft such as the Joint Strike Fighter or the 787 that have deployed lithium technology. There's been a lot of growing pains on some of those platforms, and so we start with where certification requirements are now, but the way we have to think is at scale. So instead of it being a couple hundred airplanes that we build a year, well, what if we're building 4,000 or 5,000 airplanes a year? And what if we're flying thousands of those aircraft in an urban environment? And so we actually have to look at where the standards are and exceed them. So one example of that is a current standard is a containment system that's required on a lithium-ion battery system. We're taking that a step further, where not only do we have to contain when we have a bad day, but we actually have to provide power so that the aircraft can still operate and that the pilot may get a message that he has an issue, but really has no degraded performance.
Okay, cool. So let's talk about autonomy. So the Nexus is conceived to be a piloted aircraft initially, eventually capable of autonomous flight. What are some of the challenges of designing a vehicle that can accommodate both? So, first having to supply an interface that works for a human pilot, but also design a vehicle that can be adapted for fully autonomous flight eventually.
Our initial vehicle, our technology demonstrator, will be all autonomous, and that our vision of the certified vehicle needing the capability to have a pilot on board is based on regulatory concerns plus customer acceptance or community acceptance criteria. So we're preparing for both. I think one of the things I like about going autonomy first, it helps you squeeze your schedule down a little bit, and you can get into the development flight test stage faster. So we made that choice together in order to do that, because the data that we get off of flight test is quite critical for the future state. And I think it gives us an opportunity too to then study these interceptor man-machine interfaces. We've been doing that with our future flight controls simulators, but we do that all the time with companies like Garmin. Garmin's on several Bell products, and we do that together in terms of how much data is available, how much data is absolutely essential, how do we show it to the pilot in a way where they become a safety and mission officer, and when you then add in fly-by-wire behind that and stop thinking about fly-by-wire being a means to stabilize aircraft, but rather a means to create safety in an aircraft and let that pilot be a safety and mission officer first, it's kind of natural to start from that autonomous way of thinking, because you're really just trying to augment that pilot that's there in the beginning, and then you can let go because you have the full capability already available. So it's kind of a progression through all autonomous to set up the capability, give the pilot the capability to just be a safety and mission officer, and then let the pilot come off the aircraft for the business case.
It's probably important to notice also that, to mention that the definition of a pilot is going to evolve over time. The way we see pilot today could eventually become maybe an operator that's on the aircraft whose workload maybe is minimized through more automation and things that the aircraft does. So simple things like voice communication that happen today don't really need to happen in the future. They're all data linked digital communications that the system knows how to communicate automatically to the outside world without the actual pilot doing it. So the pilot becomes really more of a safety gate to some extent, and then eventually, the pilot could find himself outside of the aircraft to where he's keeping an eye on the aircraft somewhere else, maybe on the ground or whatever that might be, and then eventually getting to a fully automated system with no human on board to operate the aircraft.
Cool. And at Didier, Garmin obviously provides a lot of avionics to a lot of the human pilots in the audience. So working on this project, how do you feel that's going to feed back into what Garmin is supplying to the larger market?
Yeah. One of the ways we look at this is to start with, maybe this is not here to necessarily replace conventional aviation or those pilots who like to fly, right? It's almost similar to how the automotive industry is looking at automation. If you like to fly, you should be able to continue to fly. So we really see those two vehicles, airspaces, and customer base coexisting together. But we think a lot of the development and technology we'll build here is actually going to also benefit pilots who like to fly. A lot of the automation and safety features that we put in here should be on general aviation, business aviation, and so on, so that in the event where a pilot gets to a safety situation, then the aircraft could help in those conditions. So we see those things as complementary.
Okay, great. So Scott, what is the vision for the flight test program? How do you see that progressing, and what are going to be some of the big milestones?
Well, the part I'm looking forward to most is the fun we're all going to have together, because it'll be another great moment where we come to the same location, a new location. We often meet today in our respective office locations, wherever they might be around the world. But the flight test moment, we're going to be in one place all together for a pretty good period of time. And I've been on several flight test programs throughout my career, and it's super fun. It's the moment that most aviation types and engineers wait for, and you get big smiles under everybody's on everybody's face when you see the air get under the tire. So that's going to be fun. I think the milestones will be leading up to that, getting great system level testing. Bell and all of our partners, we have a philosophy about what we would call aircraft zero. Aircraft zero exists in a SIL, in a laboratory environment, and sometimes it's all in one place, sometimes it's laboratories in each of the partners companies, but that aircraft, those components all speak to each other in a way that we can understand how the aircraft can fly before it flies, and then when it's flying, go back to that aircraft zero and make changes that we want to test out and place back on the aircraft. So we'll all begin that journey together as well, even prior to the flight test.
Great.
By the way, we do that with, Garmin. I see your equipment in the 525 SIL all the time, and it's that same philosophy.
Great. So, each of you is contributing some aspect of the aircraft that has unique certification challenges in terms of, this is a new vehicle, brand new kind of path towards certification. Maybe we can go down the line. For each of you, what do you see as like the big certification challenges, and how are you working with the certifying agencies to address those?
Magic of going down the line. So we initiated a discussion with the authorities, so FAA and EASA, approximately a year and a half ago. With them, as I mentioned before, we do not see any hurdles in terms of specific technologies on board. What's new is the integration level that we are reaching today. And so for us, the challenge now is to make sure we have the appropriate safety level, which is recognized by the authorities, and to define and validate the perimeter of the certification. Because when we are doing a turboshaft, it's easy, as a certification perimeter is known for decades, and so it goes to the shaft. There, we have a turbo generator, we have a battery management, we have electric distribution, we have the electric motors coupled with the propellers and inside the duct of Bell, and so we have to validate that perimeter with the authorities. That's most of the time we spend today.
For us, I think one of the biggest changes which has happened in the past couple of years or so is the certification authorities' focus on moving from prescriptive, low-level, technical-focused, solution-focused certification methods to instead operational and performance-based ways of certifying systems. So that instead of getting into the low-level detail of how we're accomplishing a function, more focusing on we're meeting the performance, the safety standards, and so on. And we have seen a shift on the Part 23 world to where the FAA has sort of renewed how they're approaching this, and we think we're going to build on top of that to tackle the unmanned systems and so on. So we were pretty positive about the industry change.
For us, what we're bringing to the table is a certified product for the demo. So of course, it's de-risk. The risk is low in terms of certification challenges for the demo. However, as Jean-Baptiste mentioned, what will be the opportunity, if I don't use the word challenge, will be to ensure that the system are integrated properly and meet the requirements. So that's something new for us. And as well, we need to make sure that we're ready for the production vehicle with the same strong building blocks we use for the demo to integrate them in the production vehicle and to make sure it's integrated properly with all the systems.
Great.
So certification around lithium-ion batteries is a topic that we could spend hours on, and there's a lot of debate around this. I think the biggest thing to mention is safety. There's a lot of things that we are doing that haven't been done in aviation before, whether it's this high a voltage bus, whereas this amount of capacity that we're actually putting on an aircraft. I think the way we address those challenges is, and how we are addressing them, is we get the regulatory authorities involved very early and very often, and we include them in a lot of the dialogue. And the FAA has actually been very supportive with emerging technologies and being adopted in this space. I think, again, I'll go to my earlier comment, we have to be able to think of thousands of airplanes and what the effects could be of that kind of a scale, and then move the bar of safety up a little higher than what we're traditionally used to.
And I just love the theme, right? In my little vision presentation that we do, we talked about early and often, and I'll give you an example right down the line here. I can't count how many times I've been visiting the FAA or Transport Canada or EASA, and they say, oh yes, well, we've talked to Thales or EPS or Garmin or Safran about it. So we have this proactive team that's out doing the early and often for their systems. We're out trying to do it early and often for the integrated system, and then we'll start to do more of it together as we approach the moment where we declare a type certification program. So that's just a testament to this group, and again, the shared vision that we found once we started to talk to each other about this type of vehicle and future market.
Great. So we're obviously at Heli-Expo. It's a helicopter show. There's a lot of helicopter operators here. What is a vehicle like this going to mean for the helicopter operators of today? How is it going to, impact the operations they're doing? What opportunities does it present, and how is it going to compete with traditional helicopters?
I think opportunity is the key word. If I had to say just one way, there's tons of opportunity in this for operators. We are interested as an OEM in that space as well, because as you look across this service model that we're talking about, there's interesting plays in the different verticals that we've never tried to be in before. But this is an opportunity. And as far as whether it replaces helicopters or not, I think Safran showed a great slide this morning on another panel we did together that it in fact doesn't interfere. These are different missions, and there's some overlap, but there's a distinction that just makes this a growth market on top of the existing market, and I think that again just spells opportunity for everybody that's in it today.
Actually, I agree with that. I think it's a complement to what we have today. So it's in between being an aircraft and a flying car. So it complements what we have in terms of driving on the road because the infrastructure is limited. The cities are getting more and more congested. There's more and more people. We want everything yesterday. So based on the culture movement, it just helps us save time and still get the job done and spend more time with family or whatever we choose to do. So it really grows with the evolution of our society. And it's an answer to alleviate some of the congestion and emission relief and all these things that we want to avoid, but still continue to actually grow and have a prosperous economy.
Obviously I deal with a lot of traditional helicopter operators, and some of them are embracing this idea, some are very skeptical of the idea of this urban air mobility. But at least 4 of you work in companies with very strong traditional, kind of helicopter or aviation-like programs. What kind of response are you getting from other people within your companies in terms of how they're, seeing this new type of project?
Well, there, as Scott said before, it's just being capable and believers. What we see there is that it's a change of paradigm. Helicopters has been existing and have been improved for decades now, and what we see today is that they have reached the potential of improvement, or very close to the limit of the potential. There we start from a blank sheet. We take benefit of the multi-rotor configuration, and we have everything to discover and a huge potential for making it better in the coming years and decades. And there we have a system where basically when we go to Safran for the propulsion side, what we see as the key requirements and design for a propulsive system are changing. The power density requirements are changing because of the batteries, because of the electric distribution. And what we believe is that tomorrow we can have an aircraft which will be quieter than the helicopter, but this is Bell to demonstrate, and they will do it. But on our side is to have a propulsive system which is more energy efficient, and which is lower cost to operate. Because today one of the barriers of the helicopters to get broader mission is the cost of operation. And the propulsive system is a significant part of the cost. And so there what we do not believe but have demonstrated is that we have a system which will significantly cut the operation cost of the operators. So we know it, we have it on paper today, we need to demonstrate physically, demonstrate to the operators, but once the philosophy is made, we are sure that the operators will look at the machine in a different way perhaps that they are having today.
So Scott, actually, with respect to operating costs, how do you see the operating costs of this aircraft compared to conventional helicopters?
There's already great signs that there's a step change between the traditional and the hybrid, and then again to the electric. So we're really encouraged about it. It's formulated based on a couple easy to understand ideas, and that is, so think of a helicopter with big rotors, complex hub, complex mechanical transmission, and a complex engine install that has a duty cycle that can be quite varied for a turbine. If you look at our vehicle, we still have the gas turbine, but it's generating electricity, so its duty cycle will eventually become quite constant, and that'll improve the maintenance intervals and the cost. Then you look at the new transmission. So our new transmission provider is Safran. It's a high voltage power transmission rather than mechanical, and that has much lower maintenance costs associated to it. Then out to the hubs, again, it's an electric motor prop rotor combination, an integrated system that has less complex components in it, less complex blades, and therefore less maintenance. Also, then the units of those pieces are more open to, let's say, or easier applied to an LRU system, a line replaceable unit system. So Nate's battery pack can come in and out. The electric motors can come in and out. And that is highly valuable. You say, well, that's still replacing the parts. But if you think about what happens today, where it's on aircraft maintenance of these complex systems, which then translates to an aircraft on the ground, which then translates to an aircraft that's not making any money for anyone. So it's a combination of that lowering of complexity and then the actual system integration itself.
Great. And I think we do have a question from the audience.
So Scott, I noticed that Moog is the partner missing from the panel today. Can you give us a little bit more insight on their role in the collaboration?
I'd love to, thank you. Yeah, Moog couldn't make it today, and I've mentioned them during the vision talks. They are contributing the flight actuators, so all the EMAs that actuate the ducts, that actuate the aerodynamic surfaces are provided by Moog, and they're a great legacy partner of ours across the military and commercial space as well, and have the same philosophy that the rest of the team has been talking about. Thank you.
Okay. So what is the timeline for seeing aircraft like this flying?
So we're talking about the middle of this decade, the middle of the 2020s, for a certified vehicle that can operate and serve customers in the commercial space.
Great. And we have another question?
Yes, we have a couple from Twitter. Can you talk about the sound of Nexus and if it's similar to a traditional helicopter?
So Jean-Baptiste was teasing me earlier that I haven't added the sound to that video that we had, and I think we need to do that pretty soon. It's pretty incredible, actually. So there's three things that have changed: the loudness, the tonality, and the directionality. And that's all been unlocked by the distributed nature of the prop rotor system and the ducts themselves. So I often tease everybody. They say, well, what does it sound like? And I say, it sounds like this. Shh. And I'm not saying shh as in quiet. I'm saying there's no longer that thump, thump, thump through the fan. It actually sounds like a fan. And if you think with me a little bit, if you're a city guy or city gal like I am and my wife is, that's the sound that highways make throughout cities in the world. It's the cars passing on the side of the road. So we're super excited about blending into ambient urban noise. And then we're super psyched about the loudness level itself, the decibels themselves. But then the ducts provide a directionality so that if we operate the vehicle correctly, knowing what's below us on the ground and below us in cruise flight and below us on the takeoff and landings, we can use that directionality to our advantage to be a better neighbor, a better citizen, a better part of the community. So we're really encouraged by that, and pretty soon we'll let that audio out.
We have one more. So just one last one on Twitter here. Can you explain the collaboration with Uber?
Yeah, so we have a collaborative partnership with Uber that places us as one of their 5 OEMs, and the Nexus team is included in that. And we're working really hard to serve the Elevate network as a customer base. Uber has 70 million or so unique users every month on their ground network, and I can't wait, quite frankly, for the day when the Uber app pops up And one of your options is no longer just scooters, bikes, and cars, but Bell Air Taxi, the Nexus Air Taxi. So really encouraged about that relationship and the opportunities it offers.
Great. So I actually took an Uber to the convention center this morning. It was a bit of an interesting experience, but it made me reflect on Uber drivers. Where do you see the pilots for these vehicles coming from initially?
Well, so I think I'll and not disparaging anyone that drives a car for a living, but we aren't the same caliber of driver or pilot than helicopter pilots or airline pilots. These are highly trained individuals. You don't necessarily get that kind of training for your own driving, nor for your Uber usage, although I feel pretty good on the road and pretty good in an Uber vehicle. So I think they come from the traditional sources initially, so the military, folks that have pursued their license as individuals. I think that's your case there, Elaine, and we're looking forward to that new set as well. We're trying to show people with Garmin's avionics displays and our control inceptors that a new breed of pilot can operate this vehicle. Think about your children and how they fly today in a video game, or think about how they use technology in a much more intuitive fashion than we ever did when we were kids. And we need to bring that into a vehicle like this using the smarts of the avionics system and the vehicle management system, using the smarts of the flight control system, and let the doors open up to a broader pilot set as well, not only just a broader customer or rider set, but a much broader pilot set, because look, training is one of the costs that factors in to the whole system, and so is piloting itself.
Cool. And Didier, how are those ideas influencing how Garmin is approaching its contribution?
Yeah, no, Scott covered a lot of this here, so I won't repeat a lot of that, but I think to some extent some of those same ideas are ones we've been pursuing for a long time in the existing market today, because we do want to simplify training. We also want to add that safety margin even for those well-trained pilots to where the system is simpler to use and so on. I'll also say that we could venture to think about some of the other technologies, more like biometrics and so on, being part of the system in the evolution to where we really know the state of the pilot because of all the sensor stuff, whether it be wearables or things like that. And so we know what the workload on the pilot looks like. We know when we can help support him through the human factors and so on. So really the part of it doesn't go away. It just becomes an easier part to integrate into the system, I'd say.
That's so cool. I didn't think about the biometrics. That's amazing.
Awesome. And I think we have another question from Twitter.
Yes. So we've heard a lot about first flight in mid-2020s. Can you talk a little bit about the infrastructure and if you expect that to be completed around the same time frame?
So I'll just clarify, mid-2020s is not first flight. That'll be much sooner than that, but it'll be the certified operational models that are out there. I'm encouraged by what I see from the infrastructure side. I think one thing that people underestimate is that there's infrastructure there today that can support the early years of this mission. There are air taxi missions out there already, and so we'll be ready for that. But I also see a lot of proactive infrastructure movements, whether it's the cellular networks, the ground infrastructure. There are great partners on the Uber team that are looking at those things. There's capability on this stage that we haven't even tapped into yet about some of those opportunities in the digital infrastructure as well as the physical infrastructure. So I'm encouraged, but it's a great question because we don't want to be in that scenario where the early electric cars, no one ever knew where they could stop to get them charged up, and I think that kind of slowed their roll a little bit, and we don't want to do that in something that takes so much upfront capital to get going.
Okay. Cool. So Nathan, one thing that we hear a lot with respect to eVTOL aircraft is that batteries are today the big limiting technology in terms of what they can do. From your perspective, where do you see battery technology progressing, and how does a hybrid vehicle like this fit into that path?
That's a great question. So I'm very encouraged to see what's happening in cell technology and how it's advancing. It's been advancing for a while, and there's a lot of money that's being put into it, and there's a lot of technologies that have been explored. I think what's also very encouraging is you look at where things are going in the automotive industry, and not only are they attacking just energy density, but cost. And cost is absolutely something that's going to be needed here to really make this type of vision a reality. I would say most of the missions that we're looking at here, battery technology is there. It's there today, and we can deploy it today. Some of the unique things that we're doing on this aircraft, looking forward to the future, is we anticipate that energy density is going to get better and better as we fly and as we operate this aircraft. So that becomes an interesting question of how do you design something to be modular or something that can be adaptable as technology continues to march along, and that's definitely something that we've taken into consideration in this design.
Very cool.
One of the things I'd like to clarify around the airframe side of that conversation too, I often say, that some of the roots of our decision to go hybrid electric was based in, some kind of desire to have batteries get better. But let's put that in context again. Remember what I said about our initial mission set, 150 miles. 150 miles an hour, 4+1, or we even showed 3+1 last year. So let's not unfairly judge the batteries on that mission set. There are tons of missions that Nate and his team could unlock for different kinds of aircraft right now, along with Safran and the other partners. So just a little context around those earlier statements that I made.
Great. So public acceptance is another, big piece of the urban air mobility puzzle. So what type of reception has this aircraft been getting, at this show and at previous shows?
Well, at CES, some of the most incredible things that were being said, and it's a reflection, again, of this team and the vehicle itself, was that we're so glad you're doing this now. I mean, can you imagine getting a better compliment from a mother or a father or an enthusiast that says, we are so glad you're doing this now? And they meant us as a team, that we were serious about it, that we were serious aerospace players. And then the vehicle itself, just as Jean-Baptiste said earlier, it speaks to our vision of safety and client comfort, and so I think that was a great couple moments. We were, and then the swarm, CES, we got swarmed really, really early, really often. So that was great to see that everybody wanted to come and check it out and take selfies with her, and that was great. So I think that's fantastic. Here, it's let's call it a more sophisticated VTOL audience, and we often internally say, well, this is a tougher show because they come and they ask the harder questions, but that's not happening because everybody here knows this is no longer if, this is when. I mean, when Boeing, Bell, Airbus, and then this week Sikorsky announced that they were getting into it, Safran, Moog, Thales, EPA, when all those players are in, it's when and who now, not if anymore. And that's been encouraging about the HAI show, because I think that's been the theme for me over the past couple of years, as you mentioned in the introduction. That may have not have been the case, but we're all here now.
Excellent. And I think we are just about out of time. Any closing thoughts from any of the panelists on what we can expect in the future, where we're headed as an industry?
Well, certainly Thales and all of us who believe this is going to revolutionize transport. It's about time. We're going to give back time. We can't create time, but this will be an element of creation of time and being able to continue to grow, prosper, do things fast, be efficient, but still in a way that gives us an ability to have a life and be the best citizens we can be.
I'll just close by thanking Team Nexus again. I mean, I talk about the journey, and one of the things I saw in all of our partners here is that they, as individual companies, looked inside themselves and said, how can we innovate? why should we innovate, and they found those answers, and then we found each other, and I couldn't be more happy with the team in that regard. So thank you very much.
Excellent. Well, great. Thank you all for the conversation, and thanks to everyone who listened to all or part of the conversation. Great. Very exciting.